Welcome back. So we're starting chapter 2, and the first few videos are all going to be about solving equations, and this is review. And so to take it one step further, we are going to do proofs with these. We call these algebraic proofs. What a proof is when each time we make a step or, say an answer, change our equation, we say why we can do that, that step. And so that's all in our properties. And so in order to do that, we have to introduce 4 properties for solving equations. And these are our properties of equality. So we first have our addition property of equality. I refer to this as APOE, A-P-O-E. And this addition property of equality means that we add equally to both sides. And then we also have our subtraction property of equality. That's going to be SPO or SPOE. Subtraction property of equality, in case you didn't understand where I got the letters from. And that just means we subtract equally from both sides. And then we move into our multiplication. So multiplication property of equality, our MPOE, M-P-O-E. That means that we multiply equally to both sides. And then division property of equality, D-P-O-E, depot, means that we divide equally from both sides. And so these are going to be our main properties, at least for the next 2 videos, when writing our 2-column proofs with our equations. And again, a proof is just saying why we can do the steps we did. So that's basically what we're going to be doing, is saying why we can do the things we did. So we always start by, when they give you the equation, your proof part. So we have our equation over here and our reasons over here. No, not next. Reasons. And you don't always have to write the equation and reasons up at the top, but that's for your understanding. On the left, we are solving our equation. On the right, we are giving our reasons. And so our first reason is that it's given to us. So when you're writing this in your work, and this is what I'm looking for in your work, you are writing the equation, and next to the equation, you're writing given, because it's given to you. And then from here, and you should know that you are subtracting 13 from both sides. If you need to write it, write it. If you don't, that's okay. On these one-step equations, I understand. Sorry, I had to remove the cat from scratching the couch. So we're subtracting both sides from 13. So we're subtracting 13 from both sides. And so 27 minus 13 is 14. And I got that by using the subtraction property of equality. And so our reasons, and so for one-step equations, our proofs are pretty simple. It's given, and then what's the one property that we use? In this case, the subtraction property of equality. So when I come over here to B, again, the first thing I'm going to write is that this was given to us. We have -7 plus equals B minus 3, and so the opposite of minus 3 is to add 3. And so I'm going to add 3, write that correctly there, to both sides. Again, if you don't have to show this, that's fine, but if you're missing problems, then it's probably best that you do start showing that. And so we end up getting that B is -4, and I got that by using that addition property of equality because we added equally to both sides. On C, again, we're going to write given next to our problem. Opposite of multiplication is division, so our inverse property is going to be to divide. 4 divided by 4 is 1, which is what we want. We want 1x, and that is equal to 6.4 divided by 4, which is 16. Or not 16, 1.6. Sorry, I had 64 divided by 4 stuck in my head. 6.4 divided by 4 is 1.6. And I got that by using the division property of equality. All right, so then on this next one, we are dividing because a fraction represents division. So we're going to multiply both sides. I'm going to go ahead and write my given next to it. So we're going to multiply both sides by 4. What that does is that makes this 1, so I have 1x equals negative 9 times 4 is a negative 36. And we got that by multiplying equally to both sides. So that's the multiplication property of equality. I've got one more example for us to go through. Example 2. So here we have 4/5 times m equals 28. We have talked about in a past video that the opposite is to use multiplicative inverses. That's the opposite of multiplying. And so the multiplicative inverse is to multiply by the reciprocal. And so since this is 4/5, I'm going to multiply by 5/4, and I will multiply both sides by 5/4. And so over here, this becomes 1, and I'm left with m. So as I'm writing that proof, I've got given for my first one, and then I'm using that multiplication property of equality. That's what I'm using for this. And so from here, I'm going to take 28, which is over 1, times 5/4. I'm going to simplify as we go. So 4 goes into 28 7 times. And so now I've got 7 times 5, which is 35, and 1 times 1, which is 1. So m equals 35. And that's my answer, and there's my proof right along with it. If you have any questions about the proof part of it, please come and ask. Otherwise, we're going to go ahead and move into two-step equations in the next video. See you there, 8th graders.